And we're back. We're back into another live stream. Because why not? Yes, we have done two live streams today. But I found out that the homework that we're doing, the next assignment, improper integrals, if you'll remember from last live stream, I found out that this thing is super easy. So we're just gonna knock it out today. So we can just study on the concepts we don't feel very comfortable with tomorrow. And then the day after that, yeah, there's really not much to say. So I'm just gonna go ahead and just share my screen. Let's do this. Where there it is. So how do we determine whether this is divergent or convergent? Well, first, divergent means it diverges to infinity, or convergent, it converges to a finite value. If it is convergent, evaluate it. If it is divergent to infinity, say your answer as inf. If it diverges to negative infinity, state it as negative inf. If it diverges without being infinity or negative infinity, how does that work? Say your answer as DAV. So here's what we're going to do. We're going to write the integral from 4 all the way to infinity of 1 over x to the power of 6 over 5 dx. Okay, well, let's evaluate that. Okay, so this equals the limit from t, that tends to infinity, of the integral from 4 to t of 1 over x to the power of 6 over 5. So evaluating the integral quickly, the antiderivative, yeah, well, this is equal to 6 to the power of negative, sorry, x to the power of negative 6 over 5, x to the power of negative 6 over 5. And the antiderivative of that is going to be x to the power of negative 5 over 5 times 1 over negative 5. What? Sorry. X to the power of negative 6 over 5. That's what I have. And the antiderivative of that. Oh, sorry, I'm stupid. So negative 6 over 5. You add 1 to that. That's plus 5 over 5. And you get, hold on, negative 6, negative 5. You add 5. So you have x to the power of negative 1 over 5. Okay, I think that's what I have. X to the power of negative 1 over 5. Yeah. And this is equal to 1 over x to the power of 1/5. Wait, well, I'm missing a bunch of things, too. So, negative, right? Chill, bro. X to the power of negative 1/5 times 1 over negative 1 over 5. This is equal to, what is 1 over negative 1 over 5? 1 over negative, so 1 over 1 over 5. So dividing by a fraction. Dividing by something is the same thing as multiplying by its reciprocal. So that's the same thing as 5. So if negative 5, x to the power of 1 over negative 1 over 5. And let's see if that's correct. You take the derivative of that, you get negative 5 times negative 1 over 5. You get x to the power of negative 6 over 5. Perfect. Looks good to me. Okay, now what? Now we do the fundamental theorem of calculus from 4 to t, and we get whoops, hold on. In fact, I'm just going to simplify this a little further. Bro, think. That's okay. Yeah, I'll just keep it like that. Perfect. So okay, good. Let's simplify further. To the power of 1/5. Where's Desmos? We have Desmos. I see. If we have, hold on. If I have 100 to the power of 1/5. Okay, so it gets lower, right? Interesting. So we get, actually, wait, and what is 4 to the power of 1/5? Okay, we get that mess. Minus infinity to the power of 1/5. Well, that'll get lower. I'm not sure what number. And infinity to the power. That's undefined. Yeah. Well, it looks like it diverges without being infinity or negative infinity. Could that be our answer? All right, so that's not the case. Okay, so that's not what it means. Diverges without being infinity. I mean, it clearly does not go to infinity or negative infinity. I mean, it's undefined. How do I put that it's undefined? Anyways, let's see. Infinity over 1/5. All right, let's go to Desmos and let's write that. Oh, for real? Why? What does that equal 0? That still equals 0. What does that mean? Oh, well, if that's 0, then lucky me then, because then I can just, very cool. Okay, I know. It was not that bad. That's cool. In fact, I think I kind of like this setup, you know? Oh, I'm doing math in the nighttime as well. You know what? Doing math every time. Life is math, you know? If the world is math, then why don't you just do math? What am I talking about? Anyways, let's keep going. So determine whether the integral is divergent or convergent, whether it diverges towards infinity or whether it converges to a finite value. If it is convergent, evaluate it. If not, state your answer as divergent. I think in the future we will get to see, without solving the integral, whether it is divergent. But right now, I don't think we have that skill, so we can't ascertain anything. 5 over x plus 3 to the power of 3 over 2 dx. So get rid of that 5. That's equal to 5. Whoops. In fact, sorry, this equals to the limit as t tends to infinity of 5 times the integral from 2 to t of 1 over x plus 3 to the power of 3 over 2 dx. So first we'll do u substitution. U equals x plus 3, and therefore du will equal dx. Very good. So that's equals the limit as t tends to infinity of 5 times the integral from 2 to t of 1 over u to the power of 3 halves du. Very good. This equals to the limit as t tends to infinity. Now we will simply do the power rule, whatever. 5, and then we will have our brackets. So 1 over u to the power of 3 halves is u to the power of negative 3 halves. Doing our, okay, and then we have u to the power of negative, u to the power of negative 1 half, I believe, times 1 over negative 1 half. Hold on. If we have 5, that's 1 over 5. Oh, so yeah, simply the reciprocal. You don't have to think of it as 1 over something. So that'll just be negative 2, right? That's the reciprocal times negative 2. You get negative 2u to the power of negative 1 half, or, okay, bro, we're running out of space. Or negative 2 over square root of u. That's what we get. Negative 2 over square root of u from 2 all the way to t. Very good. We continue. The limit from t all the way to infinity times 5 times that whatever, we get, open square brackets, negative 2 over the square root of t minus negative minus the negative 2 over square root of 2. Very good. Equals the limit as t, in fact, no, we don't need that anymore. 5 times. So the square root of infinity, how does that look like? Does that converge or diverge? Think. If I do the square root of 1.000001, that'll give me like 1.00000001. I'm asking, since the square root, to see if the square root of infinity is infinity. No, well, I mean, obviously, right? That's still infinity. Square root of infinity. That's, yeah, right. So, oh, but that's in the denominator. So negative 2 over the square root of infinity, that tends to 0, and we only have 2 over square root of 2. Oh. And that is wrong. And why is that the case? Because I'm stupid. That's why. I forgot to make sure that the bounds were modified. We did u substitution. You must modify the bounds. But it's okay. We're learning. So, if x equals 2, u equals 5. If x equals t, u equals t plus 3. For real? Okay. And actually, this is going to go, yeah, 5, square root of 5. We get that. Let's go. Let's go, everyone. Yes. Very good. Very cool. Hold on. And then after that, we have a review. Perfect. We're doing perfect on time. This is not even bad. But let's go. Let's keep going. Perfect. Same question, different problem. A different variable, W. Let's go. So this is interesting because the form of the problem is different than the one we did last time. I'm hungry. So let's see. How do we do this? So no. This is easy. One question four. Question four. Come on, we gotta hurry up. The limit as t tends to negative infinity of the square root. Sorry, the integral from t to -6 of 1 over square root of 2 minus w dw. So I believe we can either do two things: u substitution or 1 over, this looks, hold on, let's see, 1 over square root of, what is the derivative of arctan? 1 over the square root of 1 minus w x squared. We don't have that here, so we can't do that. We have to do u substitution. So u equals 2 minus w. dw thus equals negative dx. Negative 1, right? Yeah. Negative dx. So let's see. We have that. So we get for 2 because, sorry, or actually we have, so over 1/2 or just times 2. Oh, very cool. So we get, and that's just 2, yeah. 2 square root of u. Oh, that simplified so beautifully. That's so cool. Oh, a square root of negative. Oh, sorry. No. David, stop. And we forgot to modify the bounds again. What are we playing here? This is not good, but it's okay because we're learning. Um, hold on. If W is -6, U equals 8. If W is T, U equals 2 minus T. Mm-hmm. So square root of 8. That's not a perfect square, right? Yeah, so minus Okay. Finally, square root of infinity is still infinity. -2 with infinity. It diverges. Guys, I'm telling you. I mean, I think this is a very easy concept, yet it's like a very productive concept, though. It's not just like a very easy, lame concept. No, I mean, this isn't easy, but it's good. Same question, different problem. All right, this looks tougher. We have an E, but it's totally okay. We're not going to freak out. So, so how can we find the antiderivative of this? Well, oh, hold on. I mean, I think that's easy, right? Yeah. Yeah, the antiderivative of e to the power of negative x is negative e to the power of negative x, right? Yeah, so I'm not missing it, right? Um, okay. Let's see. So how does that simplify? We get negative e to the power of, okay, hold on. So e to the power of -0 is 1 over e to the power of 0, which that's 1. Mm, crap, crap. Negative infinity. 0 equals 4. Boom. Boom. Let's continue. I love these questions. They're very just straightforward. I mean, they're easy, but I think they're, I mean, good, you know? Like, what I mean is that these are straightforward questions, but we'll encounter them a lot, especially in physics and all of that. Like math. Oh, no, duh. Now, what do we have? What can we do here? And I'm not really doing a lot of problem solving here. It's just, oh, okay. Well, I mean, the U sub. Oh, I'm actually doing much better on the U sub. Let's go. Yeah. I thought I would never get that. I remember thinking it's so arbitrary, but no. But we're doing very good. And I'm getting all these right on the first try. I'm like, let's go. No, I mean, I'm not trying to brag or anything. It's just like I'm just happy that we're getting it well. All right, so we will have to do. No, actually, no, we won't have to do U sub. So the antiderivative of that, what is it? It is e to the power of negative 6t over 6, right? Yeah, so over negative 6. There you go. And if we take the derivative of that, just to make sure, we get e to the power of, wait, oh, yeah, e to the power of negative 6t. Yeah, good, good. Is from t to negative 5. No U sub, no bound modification, whatever. Oh, hold on, we bust. So that's negative 5. So negative 5. Negative 6 times negative 5 is 30. Just making sure. Wait, what? Oh, okay. Let's use a new variable for the t. Let's use, I don't know, a. Okay, now simply replacing. With negative infinity, you get e to the power of infinity over 6. That's infinity. So divergent as well. I have a feeling this is going to be wrong, but it's right. Facts over feelings. Am I right, guys? Huh, we're already in question 7. Well, that's unprecedented to the history of our live streams. Oh, we got a faithful viewer right here. I think whoever's watching this. Same question. And now we have trigonometric functions. Let's go. Oops, hold on. T. Very good. Okay. The antiderivative of sine of 9 theta is going to be negative cosine of 9 theta over theta. So oh, sorry, over 9, over 9. There we go. Because, wait, right. Okay, you take the derivative of that. You get sine of 9 theta times 9 over 9, which is just sine of 9 theta. Good. close, close. So cosine of 8 pi is cosine of 2 pi. What's cosine of 2 pi? Room, that's 1. Wait, for real? Or cosine of 0, that's 1, right? Oh, and cosine of infinity. That's gonna be like 1, 0, or negative 1. Undefined. So, but that's not infinity though. So is that still considered divergent? Hold on. So I have 1 over, okay, hold on. Let's see, let's think about this for a second. We're on a good streak. We can't stop now. Let's see. So that's obviously, it does not diverge to infinity. It obviously does not diverge to infinity. It does not diverge to infinity. Let's see. What if I do? Still, I mean, it's undefined, but like, what does that mean? Is it like undefined because it's too high or too low? All right, well, undefined, so I believe it's this then. Gotcha. Let's see. Because the cosine function oscillates between 1 and negative 1 infinitely often as t tends to infinity, the limit as t tends to infinity of cosine of t does not exist, and the integral diverges. So undefined includes divergence. Okay, it makes sense. Let's keep going. We're cooking, everyone. Let's keep doing this. Let's do this. And how long do we go in the live stream? I don't think we go very long. We only go 33 minutes. That's crazy. Oh, let's go. It's this guy again. I'm doing good. How about you? It's very good to see you again. I'm really glad you're here. Yeah. I am, and well, thank you for coming. Oh, you're doing mid? A not really good day today? What happened? Did something happen that wasn't cool or just like boring? Oh, you just woke. Oh, right. Yeah, got it. Oh, cool. I'm glad that this live stream is the first thing you see when you wake up. Let's go. Well, I hope I made your day better, right? I mean, yeah. Yeah, man. Well, I hope you have a good morning then, or whatever time you woke up. That will not be able to join. Oh, okay. That sucks. Well, that's okay. I tell him that. What should you tell him? I tell him I said hello then. All right. Yeah. Yo, is this AP Calc VC? I'm taking it next year. Very cool. Good luck with it. No, this is not AP Calc. This is actually Calc 2 in ASU. So I mean, it's different, but it covers the same concepts, probably in the later part of the course. Yeah, his college started on abs, or are you like responding for me? Oh, nabs probably then, right? His college started. Yeah. Oh, gotcha. Okay, well, we'll tell him I said good luck then. Yeah, I hope he does well in this new journey with whatever's going on. Okay. He's probably busy then, I guess, since college started. All right, man. Well, I hope you have a good day. Yeah, dude. I hope school goes well if that's what you have to use. Yeah, I'm using this graphing calculator right now. It's called Desmos. So I just do all my calculations in here. It's actually very useful, especially for like algebra heavy concepts. Yeah, bro. Yeah, man. Have a good day. But now it's time to lock back in because we're cooking and we don't want to slow down. So the integral from negative infinity to infinity of x to the first. I wonder why they put that one there. All right, I'll put that one, but okay. Times e to the power of negative x squared dx. So this equals to the limit as t tends to infinity of the integral from negative t, oh, interesting, to t. I believe that's how you do it, of x to the power of negative 1 times e to the power of negative x squared. Okay, dx. So let's integrate this. What do we get? Um, oh, so that's a product. So, oh, we'll have to use integration by parts, right? Oh boy, let's do this. So how does integration by parts go? Here, let me just pull up my notes because I don't think I remember. Okay, do we? Oh, no, no, no. I actually think we do remember the equation from the top of our head. Is it the integral? The integral of u dv equal u v minus the integral of v du. Yep, I think that's it. I'm telling you guys. So we're saying, so the limit as t tends to infinity, and then we're gonna say that. Oh, and oh wait, sorry, but before we do that, we got to choose u and v. Um, so if we let u, hold on. What? Okay, here I'm just gonna check my notes because I think I remember doing a bunch of calculations of these. Factors. Integration by parts. There we go. Yeah, the integral of u dv equals uv minus v du. Perfect. Yep, we got that. Perfect. Okay, so here we had this problem. We let u be. Oh, so you let u be a product. Uh, so hold on. U equals ln of t, and then dv is going to be. Where do you get dv though? Oh, dv has to be the rest, doesn't it? Yeah. All right. So why did I choose u equals ln of t? Because if I do that, then I get 1 over t dt, and v will be 2/3 t to the power of 3 halves. But is there any specific reason I let u equal ln of t? I don't know. Mm, I wonder. Okay, it's okay. Let's continue. Oh, you can't? Ah, okay, that sucks. Okay, man. Well, I'll see you later. I'll see you later, man. So, let's go back to our question. Question 8. So, what will we let u equal? Let's let u equal, hold on, I'm just gonna ask ChatGPT to make sure I remember. Be the part that becomes simpler. That's right. That's right. That's right. So in this case, will e to the power of negative x squared become simpler? It won't. So therefore, u equal, looks like a v, bro. We're going to get confused. U equals x. U equals x. Therefore, dv is going to equal e to the x squared dx. Du is going to equal dx and v. Oh, crap. We got to integrate that thing. The integral of e to the x squared dx, we get, all right, really easy. So, oh wait, no, hold on. Do we have to do u substitution to simply get v? Let's see. No, I don't think we have to, right? Mm, the derivative. All right, hold on. So if we do over 2x over, bro, what's going on here? So v equals, hold on. All right, gotcha. So we have to use u substitution, right? Do I have to do all of that? Why would they give me such a function? Oh, yeah, you can't use a calculator for anything? Oh, I'm sorry, man. But how? Okay, bro. Great. How do you do it here? I mean, I don't want to get stuck in this problem for too long. Oh, okay, I see. So we we did something with the u sub that we could have done differently. So if we let u equals negative x squared, du will thus equal negative 2x dx. Then our integral becomes oh, well, very easy, right? So we get negative 2 That's funny. Well, I'm just going to keep doing this just to make sure we got this right. So we took out the negative 2, so we have right. Yeah, and then there we don't have any product. Okay, well, I know how to evaluate that. But what just occurred to me, that's funny. I got this from an unknown source. But since we have the integral from negative infinity all the way to positive infinity, well, the area under the curve below the x-axis is negative. For example, if we have like the integral from negative 5 to 5, the area under the curve in the below the x-axis will cancel the one in the positive. So since here we have the same number, well, I mean, it's not a number, but still, it's the same concept. The area under the curve of the x-axis and then the one over the curve, well, it'll just cancel out. Very interesting. That's actually pretty interesting. So I found that interesting. Here, I just gotta think. Cool. So we're back. So is this also going to be 0? Yeah. All right. Cool. I I had to try though. I had to try. Wait, no, hold on. Wait, why isn't it 0 though? Oh well, okay. I mean, looks like we have a fraction, so things will probably behave differently. So let's see. So okay, we have a power in the denominator that's much greater than the numerator. You know, I don't think that helps with anything. Hold on, bro. Oh, gotcha. Here we have x to the 6. Hold on. What are the next questions? We have that, we have that. Gotcha. How long do we go? We go for 51 minutes. No, we're still good. 51 minutes is it's okay. Let's see. So what do we do? What is the derivative of that? We have a quotient of two functions. Well, I think integration by parts would be good. Oh, sorry, tangent, right? Arctangent. You can take out an 8. Should we also do integration by parts here? Or should I do U substitution? Okay. U sub it is. Well, we could do, yeah, I guess we could do, oh, no, actually doing, yep, x cubed. X cubed is probably the best idea. Then we can utilize, oh no, that's actually a very genius idea. I mean, it's a simple idea, but it's good actually. Hold on. So if we do, no, actually, it's exactly what we were trying to do. Perfect. We 3 times what is 8? 8 over 3, right? We're so good. Mm-hmm. And we replace it back with x to the third. Very good. Now we perfect. Okay. Let's just do the fundamental theorem of calculus. Bro, why? So we have arc tangent of negative t. Oh wait, whoops. I gotta put that limit back. To the whoops, and then first we do so to the t minus arc cubed minus arc tangent to the negative t, and that replace all x, so cube close. Okay, so what happens here? Yeah, so here we simply have, bro, 8/3 times arctangent of t to the third minus, oh, hold on, okay. Good. So what is arctangent of infinity? Oh, for real? Minus. So is it this number? Well, let's go. It shows that we're doing everything correctly. Can you help me in some math questions later on? Yeah, dude, I'd love to help you. Um, Here, how about you send me a Google Docs of your. No, I don't have Discord. No, I don't. I don't think I have an account. What you can do maybe is maybe like in the comments, in a community post, maybe you could send me a like a PDF of your homework, and then oh wait, sorry, but like it should be real time. Well, I mean, I could, I don't know, not a PDF. Yeah, Discord. Let's see. Yeah, I don't think I could download it, but I mean, if there are other ways, I guess I'd rather do those. Uh, are these like what kind of questions are these? Are they what were you doing? We're doing calculus. I think I forgot. Okay. No, well, uh, I mean, I want to help you, and if I like have to download Discord or something, well, I guess I'd find a way to do that. But again, if there are like other ways, if you just send me like a, I don't know, like a mini Word document of the questions you need, and I could uh do a live stream of it. I don't know. Wait, okay, cool. Well, tell me what you think, all right? And I guess I could download a Discord, and I could. Oh, or what if? How about this? What if we create our Discord, but like for this channel, so we can all chat? You know, that's fun, isn't it? Right? That's cool. Yeah, and then I could help you with your problems whenever you need help and all of that. Yeah, actually, I think that's a pretty cool idea. I think that's what a lot of YouTubers do. They just create like a Discord account for their channel, and all their subscribers chat there. Yeah, yeah, dude, that sounds like a plan. So yeah, I guess I'll see whether we can download Discord. Then I could maybe share the link in a community post or something. Yeah, that's awesome. All right, cool, dude. Well, I guess I'll tell you when we do that. 6 people are watching. That's crazy. That's unprecedented to what we've done before. Or you can make a server like in Discord, or yeah, I guess that's a thing, right? A server in Discord, or like in Minecraft. Ask it, you know. All right, man. Yeah, yeah, dude. It's okay. We can talk about. Oh yeah, Discord. Right. I'm stupid. So cool. That's awesome, man. Let's let let's discuss that. So right. Yeah, dude. That's awesome. I'd love to do that. Oh yeah, for sure, man. I'd love to chat with all of you guys. But we still got responsibility though, because we have 6 questions left. Determine whether the integral is divergent or convergent. So, oh, interesting. Okay. Well, yeah, I don't think that's divergent, but let's see. You know, anything could happen. So we have the integral from 2 to 8 of 3 over, well, writing so horribly, dude. 3 over x minus 6 squared dx. We don't have any infinity. Okay, so this is just a normal definite integral, right? So hold on. This is partial fractions, right? Oh my gosh, partial fraction vibes, right? Oh boy, here we go again. So we have a repetition. 1 over x minus 6 times x minus 6 dx. So let's go to our notes for partial fractions, and what do we get? Where's the case? Case 2, product of linear factors where some are repeated. So we get, oh boy, how am I going to remember this? We get a over x minus 4 plus, no, I mean, I have to remember this. What in the world? Obviously, I have to remember this. A over x minus 4 plus b over x minus 5 plus c over x minus 5 and all of that squared. Gotcha. Well, let's do exactly that. So a over x minus 6. Wait. Oh, wait, but what if you just have, hold on, is this quadratic? No, that's only a linear. Hold on. How do I I mean, I should know this. I should know this. Whoops. That's right. That's right. Come on, get that in your head. Let's do this. So, there you go. So, this is going to imply that. Wait, and we need to get, oh, okay, plus, uh, wait, oh, well, just plus b, right? Yeah. And that equals 1. Uh, let's see. So how do I, yeah, I can do like the system of equations thing. Um, so we have okay, let's see. So AX, well, that's equal to 0, right? Negative. Wait, AX is equal to 0? Hold on. Let me see how they do the partial fraction, the competition. Do they not do partial fractions? Wait, and why are they doing, oh boy, what? So are we doing it all wrong? I mean, I thought we were cooking actually. Hold on, which problem? Okay, we're in problem 10. Hmm. All right. Let's redo this then. I think they have a harder problem than me. Hold on. Gotcha. Okay. What did it do? Hold on. Wait, u to the power of -2. Negative. So if u to the power of -2 and the antiderivative of that, u to the power of a -1 times. So that's equal to. Right. Whoops. Oh, great. Okay. And when x is t, okay, so this. And then when x is 2, we have -4. Very good. Okay. We hold on. Did I do this right? So, okay, the 12, I think it's good. Minus. Mhm. Negative 1 over negative 10. All right, so and then all right, so we have our limit that tends to 8. I think this is going to be wrong. Yeah. Ah. Oh, hold on, wait. Okay. So here you get like 8. Why? It's not correct either. Oh, I see. You can split it. Okay, so if we split it 6, we would get hold on, wait, so 5 by 5, that I get 3 over 0. That's infinity. Negative infinity minus a 3/4, so negative infinity. And then if I do from the 6 to the 8, I'll also get negative infinity as well. So Or is it infinity since we have two negatives? Okay, I see. Gotcha. Boy, we're getting a little tired. Five questions left, y'all. Oh, let's go. Let's go. This should be easy as pie. So, effect. Let's go. That looks like I don't know, arc sign, right? Oh, gotcha. So 7 arc sine of 1. Yes. Yes. But the heck? That was not even. All right. Hold on. The integral is improper at x equals 1. Oh, okay. So I got to think of it in terms like that. Okay. All right. He did the exact same thing as me, but he had like a different perspective. Oh boy. 4 questions left. Come on, guys. Can we do it? Yes, we can. Okay. Hold on. And didn't Obama say something like that? You spoke very well. Six, seven. Interesting. Interesting. For questions. Cuatro. Okay, thanks, Mary. All right, let's lock these questions back in. So, mm, 0 point. Okay, so if we have okay, yeah. Mm-hmm. 3 questions left. Okay, hold on. And are there any more tough ones? Yo, electromagnetic theory. This is very cool physics, y'all. All right, let's finish this well. All right, I need to wake up. The improper integral from negative infinity to infinity, x dx, is 0. It's 0. Oh, wait, incorrect? What? Why? Whoops. That's, bro, didn't we literally just show that it was 0? Okay, let's think about this. So the integral of x is x squared over 2. X squared over 2. 1/2 times x squared. That's infinity minus negative infinity. Okay, oh, I see. It's probably this one then, right? That's also incorrect. Oh, gotcha, cool. Whoops. So this one? Okay. So that's considered divergent. Both negative infinity. Oh, so they cancel out, but they're still considered divergent. Oh, I see, I see. Hold on. So this one was negative infinity to infinity. It did not equal 0, but okay, I see. It does not always have to equal 0. Improper integrals, infinite limits of integration. Integrals may have infinite limits of integration. Or integrands that have singularities. Such integrals are called improper, even though there is nothing wrong with such integrals. They may have well-defined values, in which case we say they converge, or they may not, in which case we say they diverge. And this and the next problem give the value of the integral if it converges, and enter the letter D if it diverges. So it's basically giving me 6 more problems just to solve like this. Bro, well, let's do it. We have nothing to complain about. And then in electromagnetic theory, the magnetic potential U at a point on the axis of a circular coil is given by that, where A, R, and A, where big A, R, and little a are constants. Compute U. We're so close, guys. Come on. We're so close. We can finish this. And I'm hungry. I'm hungry, guys. So, oh, we got to eat. We got to eat. Dude, are you